Rice is a staple crop around the world, and here in Louisiana, it's an important part of some of our favorite dishes. Rice is also important to the economy of Louisiana. With more than 415,000 acres of the crop grown in the state, rice brings in over $400 million every year. Rice farmers in Louisiana have been able to grow a successful crop due in large part to the Variety Development Program at the LSU AgCenter's Rouse Caffey Rice Research Station. Since the early 1900s, scientists at the station near Crowley have bred and released nearly 60 varieties that were developed specifically with Louisiana needs in mind. These plants have to be able to stand up to heat and humidity and local insect and disease pressures while still providing good yields and grain quality. It's a long, complex process that requires a lot of resources, and the Ag Center is fortunate to have the support of the Louisiana rice growers who help fund breeding work through a checkoff program. Coming up with a new rice variety is a multi-year process that has many facets. Scientists examine thousands of potential new rice varieties every year. They're culled down one by one until a winner emerges. It all starts by making an initial cross of two parent rice plants. Scientists choose parents that have traits that are desirable, such as disease resistance or high yields. By combining parents with ideal qualities, the hope is their offspring will turn out to be a superior variety. But that's not how it always works. Some crosses are not significantly better than existing varieties, maybe even worse. And it's important to remember that no one plant can be the best at everything, but it may be good at one thing that makes it attractive to scientists and eventually growers. Staff at the station make about 500 new crosses using 80 parents every year. The seed from those crosses are called the F1 generation, and they're transplanted into the field for initial testing. Those rice plants are later harvested, and the seed from those plants is then used to grow the next generation, or F2, which consists of about 600,000 unique plants. The F2 plants are advanced in one of two places: a greenhouse at the station or Puerto Rico, where the Ag Center has a rice nursery. Some breeding populations are screened at the F2 generation using technology that plays an important role in helping researchers decide which plants to keep and which ones to throw out. By punching out small pieces of leaf tissue from the plants, scientists examine DNA markers that indicate important traits like disease resistance, grain quality, and plant height. About 3/4 of the material they review does not make the cut. Technology helps whittle down their choices so they can devote time and resources to the most promising lines. The F2 lines that pass visual selection or DNA testing for desirable characteristics are harvested to grow the next generation, called F3. The main objective of the F3 generation is to increase uniformity within the line in the crosses and increase seed volume. F3 seeds are planted on the station for further review. Staff plant a whole row of each line, usually about 100 per year per population. Once the plants are mature, they pick about 50 individual plants that exhibit characteristics they like to see. This process is similar for the next generation, F4. Rice rows at this stage are harvested by hand. The nursery field where they are grown has about 45,000 rows. About 4,000 of those test rows look good enough to harvest each year. Then all of that seed has to be collected, cleaned, and bagged. It is a long and laborious process that repeats each year, but it is critical to deciding the fate of these potential rice lines. Scientists carefully examine how the plant looks in the field, what its yield is like, and if the grain is of good quality. If the plant is too short or too tall, if it doesn't produce enough rice, or if the grain is chalky, the plant is cast aside. From here, about 2,000 lines are advanced to the preliminary yield testing stage, where testing becomes more serious and more detailed. Higher yields are always sought after. Resistance to disease, such as blasts that are a big problem in Louisiana, is another desirable trait that scientists screen for. The 2,000 lines in the PY stage are then narrowed down to about 180 lines to be tested in the regional yield test at 5 locations across Louisiana. The top lines from the regional yield test are advanced to the next year of testing in the advanced yield test. This round of testing lasts about 2 years. In the end, just 1 or 2 lines stand out as potential releases. The University of Arkansas, along with Nutrien and Horizon Ag, all work with the Ag Center to nominate top lines and help each other conduct the most rigorous testing of the breeding process, called the pre-commercial test. This allows the potential new rice varieties to be planted and evaluated at 25 to 30 locations in Texas and Arkansas. Once a line is selected to be released as a new variety, specialists in different disciplines evaluate the line to develop recommendations for how to grow and manage the variety in terms of fertilizer, disease, insects, and herbicides. In addition, the Ag Center has to get busy growing those plants to increase seed to release to the industry for planting. The Foundation Seed Program at the Rice Station accomplishes the seed increases and packages and provides seed to the industry if they are a publicly released variety. Some rice varieties developed at the Rice Station use Clearfield and Provisia technologies that are marketed through Horizon Ag and BASF. By the time a new variety is released, several years have passed and thousands of other contenders were eliminated from the breeding process. Rice breeding takes a lot of effort and time, but the results have a big impact on the industry. By developing new varieties that meet the changing needs of the rice industry, the LSU AgCenter is helping farmers remain profitable in growing a crop that is important in Louisiana, in other states, and worldwide.